right, so if you haven't already done so, this is going on page 121. These should look familiar, yes? This is stuff I had you write down on your notes on Monday. And so they're all of this is the same. The only difference is that it doesn't have on here basically how we came up with those, which I think is fine. But I wanted to make sure you could actually read it, not just, you know, most of you have handwriting you can actually read, but sometimes when it's small and it's all crammed together, it's just hard to separate it, so this is a little easier to look at. I think you might want to add, you don't have to, but one of the things that you use when you come up with the identities is you're not always going to end up with sine squared plus cosine squared. You might end up with 1 minus cosine squared x, right? And what does that equal? Sine squared x. Okay? So you don't have, like, you could write those, like the different forms of these three if you wanted to. So that means that 1 minus sine squared x would equal cosine squared x. That's up to you. And you could do the other two if you wanted to. That way when you glance at it, because sometimes when you put that in there, it doesn't just take its place. Like, it makes something negative if it's backwards, and it's easy to kind of mess that up. So the more you see it and think about it being 1 minus, not cosine squared minus 1, but 1 minus cosine squared, you know, and you can do the same thing over here. So it's not, even though this is sine squared and cosine plus cosine squared, here, if I had these two together, this would be secant squared x minus tangent squared x equals 1. Right? You're not adding them, you're subtracting them. Okay? And then here, this would be cosecant squared x minus cotangent squared x equals 1. Okay. Everybody good with that? So that's just better things to glance at. You know, you can add some extra little things, but if you add too much, then you're just redoing them, and that's kind of the whole point of the identities. But I wanted you to have this as a good reference. Okay, we good on that? All right, so let's look at these notes real quick. What these notes are going to help you with is when you get stuck on these and they get a little bit more complicated. No, that is not what I want. 122. It's going on 122. Just ideas of like what to do, how to get started. Okay, because some of them, it's kind of obvious where to get started. And other ones, you look at them and you're like, I'm not real sure what to do here. So in bold are the different things that you could apply. Okay, and we'll just look at like quick little examples that might show up inside of a different problem. Renaming in terms of sine and cosine can be helpful. So in this example, I already have sine x. Well, cotangent is a ratio, right? So this would be sine x times, what is cotangent in terms of sine and cosine? Good. Cosine over sine. So cosine x over sine x. So this is like sine x over 1. So what does that become? In the end, can I cancel anything? Yeah, they just cancel out, and I just get cosine of x. But even if you can look at this and you know that's what's going to happen, you don't get to jump to this. You have to have something in there that shows process, okay? Because that's kind of the whole idea here is the process. All right, Pythagorean identity. All right, so I have 1 minus sine squared x. What is that? Cosine squared x. So I get cosine squared x over cosine squared x. What does that become? 1. Like I said, all these are going to be kind of quick and short, and it's things that would happen within other ones. They're not all going to be this simple when you're using them. Okay. Then the reciprocal identity. You have to know which ones are the reciprocals of what. So secant is the reciprocal of what? Cosine. So 1 over secant x is just cosine x, and that's it. It's something I can replace it with. Quotient identity can also be called ratio identity. I think that's what it actually says on the thing I gave you, but it's the same. Ratio identity. Just so that you know it's the same thing. Bless you. So we have cosine x times the tangent of x. Well, tangent is one of the ratio identities, so this becomes cosine of x times what? What is this as a ratio? Sine x over cosine x. And this is really the same strategy as the first one for the most part. But then those cancel out, so your answer is sine x. Everybody okay with that? Any questions? All right. So then multiplying reciprocals. Basically just making sure that you know, and really a lot of these reciprocal ideas, if this is the same idea as rewriting it in terms of sine and cosine, right? Instead of secant, how can I write that? 1 over cosine. So 1 over cosine of x times cosine of x, what's that going to equal? 1. Okay. So if you multiply reciprocals, something by its reciprocal, you're just going to get 1. Things cancel out. When you're dividing reciprocals, sine over its reciprocal, which is cosecant, right? Then this is going to give me sine of x times what? Sine of x. And so you get what? Sine squared x. So if you look at this, when you multiply two things that are reciprocals of each other, you should always get 1, right? That's straight off the identity sheet. And then when you divide them, you always get the numerator squared every time. Okay. All right, so this has multiplied by 1 in disguise and then add fractions. So basically that's like getting a common denominator. So this whole 1 in disguise idea, that's how we're getting the common denominator. What would my common denominator be here? Cosine, right? So the 1 in disguise would be like cosine of x over cosine of x. That's what it means by 1 in disguise. So this is going to give me sine squared x over cosine of x plus cosine x times cosine x over cosine x, because that's how I'm going to get my common denominator. So then I get sine squared x over cosine of x plus what? What's the next fraction look like? Cosine squared x over cosine x. Now when you do something like this, especially if it's within something else and there's a lot going on, don't look at it and go, oh look, I can reduce this and reduce that, because then you're back where you started from and you're just in this vicious circle of weirdness that happens sometimes when you're doing things that look odd. So the whole reason we did this was to get a common denominator. So this is going to give me sine squared x plus cosine squared x all over cosine of x. So now what can I do? Good, simplify this to 1. This is one of my Pythagorean identities, right? Sine squared plus cosine squared is 1. So that's 1 over cosine of x, which means my answer is what? Secant. Your answers don't always have to be in sine and cosine. I think that's happened with a lot of them. They just need to not be a fraction. You're trying to get it down to one term that's not in the denominator. Okay. We all good? All right, so multiplying or dividing fractions. So we know when we divide fractions, we can multiply by the reciprocal. So dividing by tangent is the same as multiplying by the reciprocal. So this could be sine of x times, what's the reciprocal of tangent? Cotangent. Then that means I get sine of x times how can I rewrite cotangent? Cosine over sine. Which means my final answer is cosine. So when you're deciding what to do, because sometimes you have to sit there for a second and think about what would be the best thing to do, because there's multiple things. Like I could have rewritten this as cotangent like I did, and that at least gets it out of the fraction. But then at this point, I could have rewritten this as 1 over cosecant, right? Would that have helped me any? No, because the cosecant doesn't really relate to that, but you can rewrite cotangent that would relate to sine. So you kind of have to look at what you have and think about, if I did this, what would that change and where would that get me? Okay, we all good? Yes. All right, then the next one, let's see, all this. This is just reducing fractions, right? So sine squared x over sine of x is just what? Sine of x. That's it. But be careful not to do it after you get a common denominator when you meant to do it on purpose. All right, so multiplying, distributing, or foiling, and there is a pattern to this as well. So I could straight up FOIL all of it, but if I have an A minus B times A plus B situation ever, doesn't that just become A squared minus B squared? Right? The difference of two squares. So I don't have to FOIL it out and do anything like crazy long. I just need to know that that's my little shortcut there. So sine times sine is going to give me sine squared x. And then then that's minus and plus, so this is just minus 1. Okay, so does this directly match something on your identity sheet? No. It looks very, very similar, but that whole thing doesn't directly match. Does just sine squared x match something that you have? Sine squared x I can replace with what? What is sine squared x? 1 minus cosine squared x, right? And then this minus 1 right there. Okay, that's where I said, remember I said you have to be careful. It doesn't say sine squared minus 1. It says 1 minus sine squared. So this is what replaces, this is what gets replaced with that. That means then I do get 1 minus 1, so my answer is negative cosine squared x. And if you're not careful, you're going to mess up on a sign there. Okay? We good with that? All right. So then I can factor maybe GCF or difference of squares. It's possible you could get a situation that looks something like this, and maybe it's not this one because you would obviously do this, but you would need to factor the difference of two squares and know what to make it into. This one isn't a difference of two squares, but is there a GCF? Yeah, the sine squared. Could I divide a sine squared x out of both terms? See that? Okay. So I'm going to factor that out, sine squared x. Then inside that parenthesis, right, what would be left in my first term? Sine squared x, then plus what? Cosine squared x. And remember, anytime you factor out a GCF, especially if it makes you a little uncomfortable because it's not as obvious as with, A's and B's and stuff. If I distribute it back in, I should get the same thing. So sine squared times sine squared is going to give me sine to the fourth, and then those give me that. You can always double check yourself. All right, so then what can I replace this with? 1. So I get sine squared x times 1. So my answer is just sine squared x. And that's still just one term, so it's fine even though it's a squared. Because it's not like I can do anything else with it. We all good? Any questions? Then multiply by the conjugate. You talked about conjugates in Algebra 2, right? Okay. So this is the conjugate of this. Really, it's also the same as what we did right here, right? So it's the same sort of thing. You don't have to necessarily FOIL it out because you should know the pattern. So this is going to give me 1 minus what? Cosine squared x. Does that directly match something on your cheat sheet? Yes, and that answer is, I was about to put 1. Goodness gracious, it's not 1. What is it? Sine squared x, not 1. Any questions about that? Okay, so that's something you can kind of refer to when you're like, I'm stuck, what could I do here? What would be the best thing? Go ahead and glue that in. I'm going to give you the assignment, and then we're going to do one off the assignment together. Actually, I might give you a minute to start. So here was the question. The question was, if I have sine squared x plus cosine squared x equals 1. So was your question, I think you were asking me, so does that mean it's the same as if I do sine of x plus cosine of x equals 1? Okay. So the answer to that is what? No. This is not true. Okay? And here's why. At this step here, if I take the square root of both sides, this is not what I get, right? I don't get to distribute that. And so if that was true, this is a Pythagorean identity, right? And so it comes from the Pythagorean theorem. That's how we got it out of our little unit circle. So it's a squared plus b squared equals c squared. Well, if a plus b equals c, why the heck would we ever even square it also? But you don't get to just knock the squares off of both because you have this addition, right? If it was multiplication, that would work, but it doesn't work that way. Does that make sense? That's a good question, but so it's the same thing. It's still Pythagorean theorem. It's still factoring. We're still multiplying. It just looks a little bit different, okay? Anything else on that? Did y'all get it multiplied out at least? Okay, so let's look at number 12 on the homework thing. Okay, so when I multiply this out, I'm going to, FOIL is my method of choice because that's, I guess, how it was taught to me. So I'm going to get cosecant of x times the secant of x. And then the outside, now if yours are in a little bit different order, that's fine. Then I'd get plus cosecant x minus cotangent x secant x minus cotangent x. Okay, y'all agree with that? Even if yours are in a little bit of a different order? Now, this one, as far as I spaced these out and I worked them all to make sure that you had room. This one is going to take up probably the most room of all of them. That's one of the reasons we're doing it together. So don't freak out and think you don't have enough room for all the rest of them. Some of them are a whole lot shorter. Okay, so I got a lot of stuff going on. I got 4 terms, and I'm going to have to rewrite some stuff here, right? Now, I've got a lot of secant and cosecant, and remember, if I rewrite things in terms of sine and cosine, that's like my go-to thing, number 1. So I don't know that I necessarily want to change them all to sine and cosine, but I also have this cotangent in here. So if you think about what these become, bless you, this has cosecant and secant. These two are both reciprocals of what? Sine and cosine, all right? So this one is the reciprocal of what? Sine, okay? So I could get sine in my denominator. This is the reciprocal of cosine, but what's the denominator on cotangent? Sine, okay? And then this is cotangent where I could get the denominator to be sine. So if I look at the ones where I don't really have a choice, which are these two. Like, it's either this or I can change it to sine being in the denominator, right? Those two terms, I can easily make sine be in the denominator. These, I have a choice whether I want sine or cosine in the denominator. What would be the best choice? Sine, because then they'd be the same, right? So if of these 4 terms, can you get the denominators to all be the same? Yes? Can they all be sine? So let's change them, and maybe we also want to change secant to cosine. We don't know yet. Sometimes you don't know when you first start. You just got to do something. But you don't want to do everything at the beginning that you could possibly do, because then you might be doing too much, and then you end up using steps to undo it. And that may happen sometimes, and that's okay, because it's still just a process. All right, so let's change these so that sine will be in the denominator, which means cosecant times secant is going to become secant x over sine x. We agree with that? Plus 1 over sine x minus, okay, my cotangent becomes what? Cosine over sine. So this is going to be cosine x secant x over sine of x minus cotangent is what? Cosine x over sine x. Okay, so let all that sink in for a second. Make sure you agree where everything came from. Everybody okay with that? All right. So anything that we can simplify in the numerators of any of those? Cosine, what's cosine x times secant x? 1, right? Remember, if you're multiplying, isn't secant the reciprocal of cosine? Yes? So when you multiply reciprocals, doesn't this just become 1? Right? Okay. And notice, I thought about that before I started just rewriting everything. Because again, I can keep doing stuff. Y'all are good at doing stuff. You like jump in and you just do stuff. But make sure you think about what makes the most sense to move on. So now I'm going to make it all one fraction. So now I know in my numerator I can do secant x, and then this would be plus 1, right? And then minus, this is now 1, minus cosine of x, all over what? Sine of x. Everybody okay with that? All right, so what happens with the ones? They cancel out. Okay, so then this is going to give me secant of x minus cosine x all over sine x. All right. So what might we want to try next? Change secant to cosine. Okay, so let's try that. So that's going to give me, guess what I'm here, 1 over cosine of x minus cosine of x all over sine x. So what might be good to do next? Can I combine this stuff in the numerator to get one term? Look at your little, like, what to do. We can get, when you have two terms added together on those notes that we just did, that was when you could multiply by 1 in disguise so that you can add fractions. So I can add this fraction to this if I get a common denominator, right? So what would I multiply this by to get a common denominator? Cosine of x. So I'm going to multiply this by cosine of x over cosine of x, right? This is like over 1. So then that's going to give me 1 minus cosine of x times cosine of x is cosine squared x over cosine, right? So that's the numerator, and then all over sine of x. All right. So now, 1 minus cosine squared. Can I do something with that? Yes. What is that going to give you? Sine squared x. So then that gives me, and if you're starting to run out of room, which you may be, I think maybe I didn't space out enough. This is the only one that I think is an issue. If you got to go to the left a little bit, you might be okay. Up the side or whatever. So this is going to give me sine squared x over cosine of x divided by sine of x, right? So dividing by the sine of x is the same as multiplying by what? Dividing by 2 is the same as multiplying by what? 1/2. Dividing by anything is the same as multiplying by 1 over that thing. So this is the same as sine squared x over cosine of x times 1 over sine x. Can I simplify that? Yep, because this sine of x can cancel out with one of those. So that leaves me with sine x over cosine x. And what is that? Tangent. All that to get to tangent. Okay. That's the longest one on that assignment. It had the most like twists and turns in it. That's one reason why I wanted to do it with you. But do you see the thought process as you go along? You're going to have to stop and think in the middle of some of these. What is the best thing to do? And honestly, when you do it, you might do it and be like, that wasn't a good idea. I should have changed secant instead of cosecant or whatever, and go back, and that's okay. All right, it's all a process. Are we good? Okay, because after we simplify these, tomorrow we're going to start proofs, meaning I give you one side, I give you both sides, it's an equation. And you've got to take one side and make it look like the rest of them. So you need to be familiar with these and how to manipulate them. And it's just a puzzle. It's just a big math puzzle. And math puzzles are fun, right? Yes, math puzzles are fun. This is fun. Trig is fun. Okay. It's like geometry all over. Yes, yes. And that is, and these proofs that we do tomorrow, they are very formal, and it is like, it's just like that. You're not going to have to explain every step like you did in geometry and have a justification, but it's one of those where you can't skip any steps. Every painful little step, you know, sometimes you get to skip little things. Even like here where we just like crossed it out and made it 1, those kind of things aren't legal when you're proving, but it's fine here. Any questions? Do you feel maybe a little bit better about it than when you were doing your homework and struggling through it? If it's making your brain hurt a little bit, it's kind of supposed to. That's one thing that this class is you trying to struggle through it. The struggle is what makes you learn, okay? Any questions? All right, so y'all work on that, and you let me know if you have questions.